Hi, we continue with the next one. Okay, so as I mentioned earlier in the previous lecture that we learn about, how the light goes into the eye, how it get processed and all that, and we already know how the cones are actually working. Okay, now we move on to the color system. So basically, why do we need a color system? Okay, that would be the first question that should come to our mind. Okay, basically you already know how the process all happens. Okay, so once you already know the process, but now we have to think of how we can actually make this into a system, so that why do we need a system? First of all, okay, we need a system so that we can actually identify colors universally as the same. For example, if I say this is a light blue, okay, and if let's say another person see that, he might say that no, it's not light, it is like slight, more than a light color. Okay, so it is based on your perception only. So we need to have like a proper system to actually identify colors, so that it is similar for me and the person who is opposite to me or in another country or another place. Okay, so that, okay, because it is essential, because we actually need these colors, okay, for many industry, photography, fabric, okay, chemical factories. So there are many factories, industries that is actually needs the color system. Okay, that is one need. Another need is, if we have a proper color system, we have, we can identify the colors, universally, or we can give value to the colors. Okay, that will be very helpful. Okay, because if let's say we want to actually build some assessment, okay, of color vision of a person, we need to have a proper system first. When we have the system, then when we can produce the colors as we want, so that we can have like a diagnostic tool to to test the color vision. So once the color vision theory is already established with this what do you call the trichromatic theory, and also open-end process color vision theory. So this true theory is well established, and it is actually accepted universally. So there is no right or wrong. When you want to explain colors, you can use these theories. Okay, so once the theory is already accepted, then the researchers back then were actually, into the building up a proper color system. Okay, so there were many people who attempted, okay, to actually come out with the idea of, okay, I have like the better idea on how we can actually identify colors, or how we can classify, how we can reproduce colors with the system that I have. Okay, so there were two main systems that is actually, that is involved, or that is actually, okay, into, that is quite famous at that point of time. So the first one is the Munsell color appearance system, and another one is CIE color specification system. So these are the two systems very famous, back then. Okay, but only one was selected. It was not like color vision theory. Both are accepted, okay, universally. But when it comes to this color vision system, right? So there are two famous one. Okay, one is the Munsell and another one is CIE, but only CIE was accepted and actually further developed to the proper color system, while this Munsell color system is already rejected at very much earlier stage. Okay, but we're going to look into the two systems. As an optometrist, you have to know the two systems. Okay, so we're going to look at the first system, which is the Munsell color appearance system. Okay, so it's a method of classifying colors based on three attributes: hue, value, and chroma. Okay, so it is about the colors, and also the brightness, and also the saturation of the colors. So these are the three components that is used to develop this visual system, this Munsell visual system. Okay, so it was developed by Albert H. Munsell in the early 20th century. It provides a systemic way to describe and organize color in a 3D color space. Okay, so basically this Munsell color system, it is like a book that you find in the paint shop. Okay, if you go to a paint shop, you will have a booklet, okay, where you can actually see the colors and then there is a coding at the bottom. Okay, so the same concept. Okay, I think this paint shop copied from Albert Mansell actually, but the initial idea comes from Albert Mansell, where he said that, okay, all the colors from 400 to 700 nanometer, I try to put that in a booklet, but in a 3D form. It looks like more like a, tree-like, color system. So he said that he claimed that he put all the colors in the visible spectrum from 400 to 700 nanometer. So you can find all the colors. You just need to actually take like a whatever color that you want to get the number or the value of the color. You just need to take that and then you match with the colors in the pamphlet, okay, under a standard lighting. Then you will be able to match and you will be able to get the value of the color. So that was the idea of this, Albert Mansell's idea on how can a proper color vision system, is built. So the three physical dimensions or the attributes is, as I mentioned, is the hue, chroma, and value. So hue, as I mentioned much earlier, it's the wavelength. Okay, so where different wavelength have different colors. So they have like, okay, along the parameter, they have colors. Okay, the primary hues are red, yellow, green, blue, and purple. So they have 5 primary colors. And then they have another 5 of intermediaries of the colors. So that is the hue. And then the next one is the chroma, the purity or the saturation of a colors. Okay, different saturation can be found in the Mansell color tree. And also it is measured as a radius from the center of the cylindrical, ranges from 1 to 14, with the 14 denoted the highest purity. So if let's say the color has a value of, red shade have a value of 14, that means it is the purest red color. While when it gets lower by number, then it is not so pure. Okay, and then the value is the brightness of a color, whether the red color is bright or lesser bright. So increases along the vertical dimension, with 0 indicating the least reflectance and 10 is the most. Okay, so we're going to look at the picture for better understanding. So this is what I meant by the hue. Okay, they have like 5 intermediaries. Okay, they have blue, they have orange, red, and all the 5 colors, yellow and all that. So this is how it is located. Okay, the next one is the chroma. Chroma is the radius. How pure is the blue color? So if let's say it's 14, then it is the purest. Okay, if let's say 0, it is not pure anymore. Okay, so less pure. Okay, and also the brightness. Okay, so the brightness is 10 means is the most bright, and the 0 is the black color. Okay, less bright. Okay, so this is how it looks like. Okay, this is the foundation of it, and this is how it is actually built. So it comes like a color tree. Okay. So how does this Mansell works? Okay, to specify a color using the Mansell system, one would use a notation just such as 5R YR 6 stroke blue, 6 stroke 8. Okay, 5R means it represents the hue. Okay, it's the yellow red. Okay, and the 6 represents the next 6 next to it represents the value. Okay, that means how pure is the color. And 8 represents the chroma, where how bright is the color. So based on this notation is actually used to actually identify colors or label the colors. Okay, but why it was not passed to make a proper color system? Okay, so the disadvantage of this Mansell color system is, okay, they claim that they have all the 400 nanometer to 700 nanometer, but when this color system was tested for the capability in in identifying colors, okay, or identifying colors, so what happened is the the commenter is actually found that there are certain colors that cannot be, it was not found in the Munsell color system. And when this was questioned to Albert Munsell, he said that if, let's say, there are no colors, okay, in the booklet or in the Munsell color tree, he said that if, let's say, it is between 5 and 6, okay, the color is not 5 because it's too light, it cannot be 6 because it's too dark, so it is in between, okay, then you can actually write it as 5.5. Okay, and this is not convincing for the other researchers who is actually the approver of that color system. So they say that it can be 5.1, it can be 5.9, because color can vary. Okay, it doesn't mean that if it is between 5 and 6, it must be 5.5. So it is not relevant. So they have actually rejected, this Albert Munsell's work. Okay, so that is the reason why, because of that drawback, because they cannot have all the colors in the visible spectrum in their Munsell color system, so they got rejected. Okay, thank you.